Part 3. You may have figured out by now that scientists use letter symbols to represent molecules. There are two types of numbers that are used when writing a formula for a molecule: the coefficient and the subscript. The subscript tells you how many atoms are in a molecule. This is written as a small number right after the atom symbol, like we did up in these ones. If there is no number, it's assumed to be 1. In the chemical formula 3C6H5NH2, what is the subscript for carbon? Now the subscript, remember, is written as a small number after the atom symbol. Go ahead and pause the video and find the subscript for these two before I give you the answer. Okay, we have our C, and it has a subscript right here of 6. And it says, what is the subscript for hydrogen? This is a little bit of a trick question because look, there are 2 hydrogens. So what do we put? We have a subscript of 5 and we have a subscript of 2. Okay, a subscript of 5 and a subscript of 2. So there's going to be 2 answers for that one. The coefficient tells you how many molecules there are. This is written as a full-sized number at the beginning of the molecule formula. If there is no number, it's assumed to be 1. Question 5. In the chemical formula 3C6H5NH2, how many molecules are there? Well, we just learned the coefficient is what tells you how many molecules there are. So which one of these numbers is the coefficient? Well, we know that it says this is written as a full-sized number at the beginning of the molecule formula or molecular formula. So the number at the beginning is our coefficient. That number tells us how many molecules there are. So go ahead and write the answer. The number here is 3. So we have 3 of these molecules, okay? Now I'm going to go ahead and draw out this molecule. I'm going to draw out this molecule so that we can see what it looks like. It has 6 carbons, and in this molecule, the carbons are arranged in a ring. You don't have to know how to draw this. I'm just showing you this for an example. It has 1 nitrogen. Remember the subscript, if there's no number beside it, we assume that it's a 1. And then it's got little hydrogens sticking out. And bonds, these are all bonded together. And then we have, remember there were 2 extra hydrogens, that's because they're sticking out of the nitrogen over here. This is what this molecule looks like, okay? We're showing that there are 3 of them. I just drew 1, okay? So let's keep this in mind when we answer this question, okay? How many nitrogen atoms are there? We don't just have 1 molecule. We have 3 molecules, okay? So if we have 3 of these, okay, now we have 3 molecules because our coefficient said 3, and we know that there were 3 molecules. How many nitrogen atoms are there with 3 molecules? Well, there's 1 here, there's 1 here, nitrogen, nitrogen, nitrogen. So 1, 2, 3. So when we have 3 molecules, and each molecule only has 1 nitrogen, then we have 3 nitrogen atoms. Okay. How many carbon atoms are there? Please pause this video and try and figure that out for yourself before I give you the answer. Okay, we know that there are 1, 2, 3, 4, 5, 6. Our subscript said 6 in this molecule. However, we don't just have 1 molecule, we have 1, 2, 3 molecules. So how many carbon atoms are there? Let's count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. 18 happens to be 3 times 6. So 3 times 6 is 18. We have 3 molecules, 6 carbons in each molecule. So we have 18 carbon atoms. Question 6, practice. Write the chemical formula for each picture of molecules. Hint, in chemical formulas, hydrogen is rarely written as the first atom in the formula. We're going to do this first one as an example together, and then I'm going to ask you to pause the video and try the other two. Okay, this first one, in case you can't see, that is an N. So we know there's an N, which is nitrogen. And there are 3 hydrogens. So we know our chemical formula is going to have an N. So let's write an N, okay? We know our chemical formula is also going to have a number of H's, right? So we have H, okay? So we've gotten all of the atoms in our chemical. Now we need to worry about the subscripts and the coefficients. Okay, let's talk about the coefficient first. Remember, the coefficient is the number that comes before the molecule to tell you how many molecules there are. Well, how many molecules are there and how can you tell? Well, there's bonds. They are all bonded together. There's nothing that's separated. So you know that this is all one molecule. Now, with coefficients, if there's 1, we don't write the 1 right here. We leave it blank. If there's no coefficient, we assume that that means 1. Okay, now let's do subscripts to tell us how many of each atom there are. I have a 1 nitrogen, and the subscripts are just like the coefficients, that if there's just 1, you don't need to write it, you just assume it's 1. But I have 1, 2, 3 hydrogens. So the subscript that I put here is going to be 3 to show that there are 3 hydrogens. So there's 1 molecule, and this molecule has 1 nitrogen and 3 hydrogens, NH3. Go ahead and pause the video and try these next 2 before I give you the answers. Okay, let's look at this one. This one has a carbon and an oxygen and an oxygen and an oxygen and a carbon and oxygen, oxygen, carbon, oxygen, oxygen, carbon, oxygen, 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 carbon. So these middle ones are all carbons and the outside ones are all oxygens. So we're just going to write, we just have C's and we just have O's, just C's and O's. We're going to write C, we're going to write O. Now let's go with our coefficient. What number goes before here? Well, how many molecules do we have here? We can see that this and this and this are all bonded together as represented by these lines, but they're not bonded to these ones, so they're separate. This is a molecule, this is a molecule, this is a molecule, so we have 1, 2, 3, 4, 5 molecules. Our coefficient is going to be 5. Well, how many C's do we have? Well, we have 1, 2, 3, 4, 5 C's here in this group. However, once we get the coefficient in, the rest of this stands for 1 molecule. So how many C's do we have in a single molecule? Here is a single molecule right here, and it only has 1 C. Do we write the 1? No, we leave it blank, and the 1 is assumed. How many O's do we have? It looks like we have 1, 2 in the molecule. So we're going to put a subscript of a 2 next to the 1. So we have 5 molecules, and in each molecule there's 1 C and 2 O's. All right, this last one. We have in each molecule there's 1 C. That middle molecule is that middle atom is a C. And then we have 1, 2, 3, 4 H's, 4 hydrogens on the outside. So we have a C and we have H's. Let's figure out the coefficient. How many of those do we have? We've got 1 molecule, 2 molecule, 3 molecules. So we have 3 of those molecules. How many C's do we have in each molecule? There's just 1, so we don't write anything. How many H's are there in each molecule? 1, 2, 3, 4 in each molecule. So these are the formulas that you should have written. Part 4, background. In a chemical reaction, bonds of molecules are broken and reformed. An example of a chemical reaction is as follows. CH4 plus 2O2 yields CO2 plus 2H2O. And this should be left side. This is incorrect. I recross that out and correct it. On the left side of the equation are the reactants. Reactants are the substances that come together in the reaction. On the right side, everybody please correct your worksheets. On the right side are the products. Products are what results after the reaction has taken place. In the middle, there is an arrow. This arrow indicates that a reaction is happening. When you read the formula out loud, you say it yields. For example, one reactant plus another reactant yields the product. That's how you say that out loud. Here's an example. This shows you the reactants are here, the products are here. This shows you that the reaction is taking place. Question 7. For the following reactions, write the reactants and products. We know that on the left side of our reactants and on the right side are our products. So in this one, 2H2 is one of our reactants and O2 is one of our reactants because those are on the right side. Please go ahead and pause the video and see if you can fill out these 5 blanks before moving on. Go ahead and pause the video. Okay, the products here are 2H2O. That's our product. Okay, what about in this one? Our reactants here are 2Na and Cl. And our reactants is 2NaCl. And that's it. Okay, in this one, SO3 is one of our reactants. And H2O is another one of our reactants. H2SO4 is our product because it's on the right side of the arrow. Reactants on this side, products on that side. Question 8. For the above reactions, which are repeated below, how many of each atom are in the reactants? Okay, you should be able to answer this based on what we've learned. Please pause the video now and see if you can figure out how many of each of these atoms are in the reactants. All right, in this first one, we're looking at H's. How many H's do we have? Well, we have a molecule with 2 H's in each molecule because that's what the subscript tells us. So that's 2 hydrogens, but we have 2 of those molecules. So we have 2 molecules, each having 2 hydrogens. 2 times 2 is 4 hydrogen. The oxygen, we have a molecule that has 2 oxygens in each molecule. And since it doesn't have a coefficient, we assume that that's 1. So that means we have 2 oxygen in the reactants. Now we could go on and figure out how many hydrogens there are here and how many oxygens there are here. However, the question wants to know how many are in the reactants, not the product. So we're going to skip that. All right, here we have 2Na, and it doesn't have a subscript. So it's just 2 molecules. And in this case, it's not actually a molecule. It's just 2 sodium atoms. So that one's easy. We're going to put 2 sodium atoms. Our chlorine does not have a coefficient, so there's only 1 of those molecules, but each molecule has 2 chlorine in it. So there are also 2 chlorine. We're going to ignore this because this is a product, not a reactant, and our question asks for reactants. Lastly, we have SO3 plus H2O. Okay, so how many S's do we have? We have 1 here, and it doesn't have a coefficient, and it doesn't have a subscript. So there's only 1 of those S's. How many O's do we have? Well, in our SO3, this does have a subscript. We have 3 O's, and there's no coefficient. So there's just 1 of those. 1 times 3 is 3. But wait, there's also an O here, and that is still in the reactants. So we have 3 O's here, but we also have 1 here. And it doesn't have a subscript or a coefficient. So 3 plus 1. So 3 oxygen plus 1 oxygen equals 4 oxygen. We have 4 oxygen. All right, last, how many hydrogen do we have? Well, there's none in this molecule, but there's one right here. It doesn't have a coefficient, so there's just one of that molecule, but there are 2 hydrogen in each molecule. 1 times 2 is 2 hydrogen. All right, lastly, question 9. Why do we use symbols to write chemical reactions instead of always drawing out the molecules like we did here and like we did here? Why would we use symbols to do it? Think about how you did all of this and how that compares to writing chemical reactions. Why would we have this shorthand? Why would we do these symbols instead of always drawing them out? Please go ahead and write your answer right here. I'm not going to give you the answer for this one. You have a couple minutes to finish that.